Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on force exerted by the jet on a stationary inclined plate. Exactly the same derivations we have done in our last lecture, like how to identify the force exerted by the jet of stationary inclined plate, and what is the equation also we have identified in our last lecture. So based on that equation, we'll solve this problem. So the question is given here: a jet of water of diameter 75 millimeter moving with a velocity of 25 meter per second strikes a fixed plate in such a way that angle between the jet and plate is given 60 degree, and find the force exerted by the jet on the plate. First one, in the direction normal to the plate and in the direction of the jet. So very simple question is given based on the theory, like derivations what we've done in the last class. Based on that same question is given. So first one, I'll draw a schematic view of this question. Suppose this is the jet of the fluid which is moving with a velocity of v, and this is the jet of fluid and which is striking a plate. So striking a plate which is in inclined condition, and this is stationary. The plate is in stationary condition. Okay. If nothing is given stationary, what is not given in this, then some velocity should be given for the plate. If it is not given, then we can assume that this is the stationary conditions. So this is the plate, and which makes an angle of theta, that is nothing but 60 degree. Okay, there is nothing but 60 degree here, and this is the fx. So what we need to calculate here, the force exerted by the jet. So this is the jet of water. So what is the force exerted by the jet on the plate? And by two methods. First one is direction normal to the plate. So this is inclined. So normal to the plate means we need to draw a perpendicular, this one, and similarly we can draw here also. So this is normal to the plate. So this is nothing but Fn, and here also you can write this is Fn, and this Fn will make an angle of, this is, we can write as this is 90 degree. You can see it may be slightly angle is there, but it is 90 degree actually. So this one we can write this is 90 minus theta. So 90 minus theta is nothing but this 90 minus 60 degrees there. Anyway, so this is the diagram of this. So first we'll find, let's write down the data given, what is given here. So for the solution, we can write jet of water diameter. First one is diameter D is given 75 millimeter, and this one let convert into meter, that is 0.075 meter. And from here we can find out the area A. So area is nothing but pi by 4. This is D square. This you put the value of D here, that is nothing but 0.075 whole square. And the velocity of jet is given 25 meter per second. So the V is given 25 meter per second, and the next is given angle between the jet and plate. So theta equal to 60 degree. So theta equal to 60 degree. And first point we need to find out the force exerted by the jet of water. So the force exerted by the jet of water in the direction jet exerted, by the jet of, you can write jet of water on the plate. The condition what will consider, in the direction normal to the plate, in the direction normal to the plate. So this is the first condition actually, normal to the plate. So in our last lecture we have already identified what is the formula for this. Fn equal to, we found there, rho a v square into sine theta. Okay, this one also how we identified, I can give a hint on this. This is nothing but Fn equal to this is mass into acceleration. Again, here we can write mass into this is dv by dt, and this one we can consider again, this is mass by, you can write mass by time, this one mass by time, and this is velocity v1, v1 minus v2, change in velocity. So again, mass by time we can write, this is in the in place of mass we can write rho into volume, because we know the density equal to mass by volume. So mass equal to density into volume by time, and this is v1 minus v2. So this velocity by time is nothing but, sorry, volume by time we can write, this is nothing but discharge of the water. So that is q. So rho into q, this is v1 minus v2. Again, in place of q I can write this is rho av. Here I can v1 minus v2. This is our fn. So the same thing we got here, rho av. Again, here initial velocity minus final velocity. The velocity in the component, in this component, what is the velocity is there. So by that we have identified this equation. So very simple, we need to calculate this rho equal to, we know that this is water, we can consider this is 1000. Area we need to calculate, area we need to calculate here. Then velocity value is already given, this is 25 square into sine 60 degree. So then we can get it the answer. So let's find out. So first we'll find out this pi into this one, 0.075 square into pi equal to divided by 4, 0.0044. This one 0.0044. We can write this 0.00441, 0.00417 meter square. Similarly, here also the same value, I'll write it here, 0.004417. Okay. So let multiply with this one into this is 1000. Again multiply into 25 into 25. Okay, 267. Okay, then next is we need to go for the multiply trigonometric value sine 60. Okay, sine 60. So here no, it is not like that actually. It was taken differently. So first of all, what I'll do, otherwise I'll go for this trigonometric value. This is sine. Okay, anyway, sine 60. Okay, sine 60 we can write in this way. Then multiply of this 1000 into 625 into 0.004417. Okay, 2390.77. So this is the answer actually. We need to be careful while calculating this one. So this is 2390.7 Newton, and this is the force exerted by the jet of water on the plate when it is in the normal direction to the plate. And the second concept is we need to find out in the direction of jet. So in the direction of jet is nothing but this is fx. Okay, so that is nothing but fx equal to, here also we know that the formula, this is rho a v square, this is sine square theta. Okay, so here in nothing but that fn, what we got here, if we resolve this fn in the x direction, then we can write fn into this cos 90 minus theta, that is sine theta multiply of the sine theta. That's why you got rho a v square sine square theta. So here also we'll write this value. Again, this is 1000. Again, this is 0.004417, and this is again 625, and this one sine square theta. This is sine square 60 degree. So finally we'll get this value fx equal to, so let's find out this. Okay, let's make it 0, and this one we'll write in this way, sine square theta, this is square. Okay, multiply of, no, this is the method, let's see again. Yeah, initially this is 60, and this is sine of 60, sine square theta, and this one square. and sine square theta, yeah, multiply, this is 1000 multiply 625 and multiply 0.004417, yeah, 2070. This is the final answer, 2070 point, suppose 4 is there, this much Newton. Okay, I hope you understand. This is very simple to solve the problem if you know the formula of these two, like what is the fx value is there and what is the fn value is there. If you don't know also, you can easily identify what is the equation for this will be, can be how to calculate this one. You can calculate the value of fn from this diagram. Also you can calculate the fx from this diagram also. Fx is nothing but the component of fn, and fn is nothing but we need to find out the force as this method as I told you. So this thing, same thing also I have already explained in our previous lecture, while we derived the force exerted by the jet on a stationary inclined plate. So I hope you understand this lecture. Still, if you are having doubt in this, you can give a comment on the comment box. Thank you all.